Pyroclastic density currents are avalanches of hot volcanic rocks and gas that race outwards from volcanoes and more than often destroy everything in their path. Pyroclastic density currents are responsible for roughly 1/3 of volcanic fatalities globally. Here in Aotearoa, New Zealand, all of our volcanoes are capable of producing pyroclastic density currents, and they are responsible for 2 of our most lethal and most recent volcanic disasters. We cannot yet measure directly into real-world pyroclastic density currents because they are far too dangerous. That's why here at Massey University we synthesize them in large-scale experiments in this facility.
My name is Anna Pertu. I'm a PhD student here at Massey University at the PELE facility. I am studying infrasound from pyroclastic density currents. Infrasound is sound below human hearing, and we're working in the lab here to determine if we can use infrasound in the field to look inside pyroclastic density currents.
So the way these experiments work is that we collect volcanic particles, pumice and ash from Taupo, from an eruption that occurred roughly 2,000 years ago. We bring this material down here, we dry it, we put it into a large hopper and heat it for a period of days to weeks. Once that material is released from the hopper, it falls into an instrumented channel, forming an experimental pyroclastic density current.
Hi, I'm Jeff. I'm from France and I'm doing my PhD here at Massey in the PELE facility with Gert Lube. So I'm studying the interaction between pyroclastic density currents or PDC with water and how they are able to move across the water and generate or not tsunamis.
There are 2 main goals behind all of our experiments. The first one really is to get a view inside pyroclastic density currents, to understand how they are behaving and why they are behaving a certain way. How these flows are able to propagate over natural terrain and how they can destroy buildings. The second reason is to measure inside these flows and use these measurements to test and validate volcanic hazard models, so that in the future we can rely on them and predict volcanic hazard with confidence.